Hello, we are live again here at Build 2015 edition. We're in the Moscone Center, and I'm here with Anders. How are you?
I'm doing well.
Now, you do a couple of things for Microsoft. What is it that you do?
Well,
Everybody knows, but tell us anyways.
Well, I've been doing some C# there for quite a long time, and now I work on TypeScript a bunch.
It's catching fire. I mean, everybody is using this. What was the one announcement that was pretty exciting just a little bit ago about TypeScript? Tell us about that.
Well, we announced, actually Google announced, the Angular team at Google announced that they're using TypeScript to implement Angular 2.0. And this was sort of the outcome of a collaboration that we've had with them starting sometime late last year, where we met up with the team and sort of found, that, hey, we actually have a lot of overlapping interests here and common ground, and why don't we collaborate? Since it's open source anyway, we might as well do this together. And it's been great. And we continue to meet with them often and work on problems in the Angular TypeScript space. So.
Now, Angular is a substantial framework to test TypeScript on. What kind of success have they had with that?
Well, I think, for them, they sort of have come to realize as you write a large code base that there's a lot of value in having static types in there because you can check the code before it runs as opposed to while it's running. And I think for them also, for documentation purposes, types make a lot of sense because ultimately when you're writing a framework, you end up with tons of entry points and things that need documentation, and you need to write it down somehow in a consistent manner, and using static types and in a type system makes just tons of sense.
So for those that are new to TypeScript, what is it that TypeScript is doing? How does the process go from writing TypeScript to actually generating JavaScript? What is it all about?
Well, so TypeScript is a statically typed or optionally typed superset of JavaScript that compiles to plain JavaScript.
I see.
And so it allows us to have, during development time, it allows you to have static types in your JavaScript program, and those static types can guide intelligent tooling. So you can get wonderful features like statement completion and find all references, go to definition, and refactorings that are safe. But then once you compile, all the types evaporate, and you're just left with plain JavaScript. So that's number one thing it does. The other thing it does is it's a down-leveling transpiler.
I see.
Meaning that you can use, as we say, features from the future today. You can use ECMAScript 6 features and down-level compile them to ECMAScript 5 or ECMAScript 3 JavaScript that'll run in any browser. Because even though ECMAScript 6 is close to ratification as a standard, it's going to be years and years before browsers actually, before you can assume in your apps that the target browser supports ECMAScript 6. Even today, you can't really assume ECMAScript 5, even though ECMAScript 5 is almost like 5 years old now, right?
So would you say that TypeScript, the language, is a bridge to what's coming in the future? Is TypeScript going to be not necessary when the next version of ECMAScript?
No, because this is just the cycle repeats, right? Then we're already now implementing some features from ECMAScript 7, or proposed features from ECMAScript 7, like async await, like decorators, for example, and that cycle will, as long as JavaScript keeps evolving, you'll have this same cycle.
That's cool. So I went on to GitHub, and because TypeScript's open source on GitHub, and I see here design goals. And the reason I like this is because once you're clear about what TypeScript is versus what it isn't, it's really easy to make decisions about the kind of features that you have. So there was one I had a question about. Let's take a look at this. So produce a language that is composable and easy to reason about. Easy for the programmer, easy for the transpiler. What does that goal mean?
Well, it's like motherhood and apple pie, right? Who doesn't want that? I do think that easy to reason about means, ideally there's not more than one way of doing a particular thing, right? Some languages over time end up with a lot of cruft and tons of different ways of doing stuff. Composable, I think, one of the, at least to me, what that means or has meant is, the ability to use the language not just as a traditional command line compiler, but the ability to embed it in tool sets in a variety of different places. And you see that now that we have IDE plugins for God knows how many different IDEs, right? Like, well, of course, Visual Studio and the new Visual Studio Code, but also WebStorm, Sublime Text, Atom, Eclipse. I mean, the list goes on, you know, of great plugins that give you all of these advantages that I talked about earlier, like statement completion and refactoring and so forth.
Well, that's cool. Well, we have some questions coming in. Christian says, now that TypeScript supports ES6 modules, is the old module syntax being deprecated?
That's an excellent question. It's not. Well, it depends on what you mean by deprecated. We will continue to support it, and it's not going to go away. But we will definitely encourage people to use the new ECMAScript 6 standard for modules, right? And I think everyone is going to want to do that. But we are very conscious of not breaking code. And so backwards compatibility is king. Now we are doing some renaming of modules. We used to have two kinds of modules, and we still do, or things that we called modules. We had what we called internal modules or namespace modules, or sort of the ability to create an object rooted in a global namespace with objects inside it, and then a dotted path into it. And then we had what we called external modules, which is CommonJS and AMD modules. We're renaming that terminology. We're calling the old internal modules, we're going to call them namespaces.
Okay.
And the new modules that we used to call external modules, we're just going to call them modules. Because that's what ECMAScript 6 calls them.
I see.
So from here on out, module in TypeScript means an ECMAScript 6 module.
Got it.
And namespace means the namespace kind of internal modules that we previously had.
Be able to dot down into stuff.
Yeah, but both will continue to be supported. We are adding, we just added last week, a new namespace keyword that you can use instead of the module keyword, just because it just makes things make more sense, but it's all optional again. So.
It feels like TypeScript has a set of features that you can either opt in or opt out. You can write plain JavaScript in TypeScript and everything's okay.
Sure, I mean, if you do that, then TypeScript really functions as a linter, right? It just tries to infer best it can, and it can only go so far without type annotations, but it still will point out a bunch of stuff. But then as you add types, you can sort of gradually dial up the help, and you can even dial it up to a point where you say, I would like you to verify that everything has a known type in this program.
Okay.
Because, and then we even have, it's called the no implicit any compiler flag. And once you turn that on, you have an assurance that refactorings are safe.
Okay.
Because nothing has a unknown type. And therefore, we know what everything belongs to, and therefore you can refactor it safely.
And I think there's power in that, especially when you're building something that's really large.
Yeah, I'd say the larger it is, the more applicable TypeScript is, right? And as you get into really large teams and many people working on it, it's just an invaluable development tool.
Got it. So another question: how secure is TypeScript code? How does TypeScript handle functions like eval, which often causes some problems in JavaScript?
Yeah, well, TypeScript doesn't handle eval in any particular, because TypeScript is a development tool, not a runtime tool.
Got it.
So we don't make any guarantees about what's going to happen at runtime. It is up to you or the runtime environment not to use eval. What we do is we give safe types to everything, so we reduce sort of the chances of something going wrong, right? But we can't, as a compiler, ensure that you don't do this, because you can do anything you can in JavaScript. Right?
All right. So Thomas says, can you do algebraic data types with TypeScript, unit types, recursive data types? That's an interesting question.
Well, so ADTs are a kind of types that are found in functional programming languages, and you pretty much can. We have union types in TypeScript. We certainly have recursive data types, or types that depend on themselves in their own definition, absolutely. We are looking at doing some language extensions that would allow us to do matching also over types that have a known qualifier or discriminant.
Like pattern matching.
It's kind of like pattern matching, although it's more. It's not going to look exactly the same. There's on our website there actually, or on the GitHub site, there's a couple of proposals for some of that stuff, so you can find it up there. Yeah.
That's cool. Okay, next question. Any plans to support TypeScript even some types, something like var?
Yeah.
Maybe explain the question a little bit.
Yes.
That way
so
people know
it's a good question. Yeah. The question is, are we going to support types like this type is both an A and a B?
I see.
Like where you mix together two types.
Got it.
And some types indeed would be useful for mix-ins, where you sort of mix in some members from another type. And it's something that we're thinking of. You can sort of do it today with inheritance. I mean, because that in a sense creates a sum type, right? But it's not a type operator, and we're looking at doing that. We have intersection types now, or union types.
Okay.
But we don't have sum types. Yeah.
All right. So Phil asked, could the TypeScript compiler support double quotes for string templates, additionally to backticks, because backticks are hard to type in non-US keyboards?
Yeah, probably not. I mean, because we already have. JavaScript already has defined backtick to be the one that you use for template strings, and if we were to add another one, I think it would add more confusion. I mean, it may solve a problem, but then it's going to create another problem.
Right.
And at that point, it's not clear to me that it's worth the trade-off. Yeah.
So let's talk about some of the new stuff, because it looks like you're on GitHub. What's the process for your design? Do you have the design notes online? Can people contribute to that?
Yes, and yes, they can.
Nice.
And we basically, the sort of life cycle of a feature typically starts with an issue or a suggestion. I mean, well, they're all called issues on GitHub, but it's tagged suggestion. Typically, someone will write up a suggestion, and we do that even for the features that we implement, but of course the community will suggest stuff, and then a discussion will ensue, and then we will triage these suggestions in the TypeScript development team, and then we'll either tag it like, okay, we're going to accept pull requests on this one if someone wants to do it, or we're going to commit to doing it, depending. But we basically treat all features, our own versus community, the same way. It's the same process, and
That's awesome.
It's all in the open. Yeah.
So what are some of the new things coming out here that people can look forward to in TypeScript?
Well, so right now we're on a fast track to finish ECMAScript 6. Right?
Okay.
We just today announced TypeScript 1.5 beta, which takes us from, TypeScript 1.5 takes us from implementing a few ECMAScript 6 features to only lacking a few ECMAScript 6 features.
Got it.
We pretty much jumped and we now cover the broad majority of features, but there are still some, like generators are not in yet, that we need to finish off, and that's what we're going to look at doing in TypeScript 1.6. We're also looking at spiking some ECMAScript 7 features.
Interesting.
We've already implemented decorators. We're looking at async await. We have an experimental branch that we're going to merge in, I think, in 1.6. And then we're looking at module bundling, and then finishing off ECMAScript 6. Though that's sort of like, that's going to keep us busy for probably the remainder of the next 6 months, I would say.
Got it. Okay, so another question. Do you have any plans to improve workflows and packaging of TypeScript and or JavaScript code as part of a TypeScript project, like JSPM?
Yes, one feature I mentioned here, module bundling, is something that we will likely add to the compiler itself. The ability to, inside a project, use ECMAScript 6 modules for all of your code, but then bundle it together and produce a single output file out of that, where all those modules are sort of bound together, but they can still have external dependencies, and things can have dependencies on them. That's a feature that we lack today, and for that reason, if you're using modules in a browser, you need a module loader or a module packager like JSPM or Require.js in order to load and run your modules.
Got it.
So for sure, that's something. But in general, I think we also have we sort of have the point of view that we want to play well with it. We can't do everything.
Yeah.
And so it's going to always be important for us to just be able to plug into pipelines of JavaScript tooling And for example, if you don't like the way we're going to bundle modules, well, you can always use TypeScript to produce ECMAScript 6 output and then use another transpiler to do your bundling. And people do different, they put it together in different ways, and we're sort of committed to fitting into the process well, but also picking sort of an 80-90% case that we want to plumb all the way through.
Got it.
And make efficient. Because as you snap together long tool chains, something's got to give. It starts to go slower, right? I mean, so if you care about performance, that is not always ideal. So
I see.
It's always a trade-off. Yeah.
All right. So another question from Blake: are you going to spend any time improving the developer experience when working with things like Karma? Writing tests in TypeScript today is a little difficult. Now, is Karma a testing framework?
I believe so. Yeah. I think. Yeah. I mean, we're always looking at the tooling. I think. For the last year or so, we have been very heads down on just we got to get ECMAScript 6 done.
Got it.
Because that's what the community wants. For a lot of these things, we do work a bunch with the community on these things. And so, for example, build tools, we have great support in Grunt and in Gulp, and we have great support in a variety of IDEs. And unit testing, I think, is another area where we could perhaps take more input from the community. Yeah.
Got it. So it looks like some people are asking some C# questions. So let's talk a little bit about C#. What are some of the new things in C# coming out now? And tell us a little bit about C# for the future. How do you envision it? So first, what we're coming up with now, and then future.
Well, so C# 6 is just about to ship, right? In Visual Studio 2015, and C# 6 is a fairly lightweight release language-wise. There are a bunch of smaller features in there, like the Elvis operator, the question mark dot operator, for example, is one that comes to mind, right? But the sort of crux of C# 6 and of this last product cycle has been finishing Roslyn and moving on to that new compiler code base, which is what we have done. And literally in VS 2015, we have a brand new compiler. It's a new, brand new code base, brand new IDE with a lot of cool new features and much better extensibility. And it's all open source.
And that's a tremendously difficult undertaking.
It's writing a compiler is hard. Writing a compiler for a language that is a decade old and has millions of users, where you gotta be backwards compatible with every little bit.
Because it might have been that the old compiler was quirky with some part of the language, and the new one has to be quirky too.
There were quirks, and then now you sort of, what do? Do I implement the quirk, or do I implement it the right way? But then I will break something, right? And so all of these things you got to consider, but.
That's crazy. So what about the future of C#? Where do you see C#?
We're starting the C# 7 design process right now, actually, or in the last couple of months. And we're looking at things like nullable types is a big one. And there's a whole, we have it's all on GitHub. I would urge you all to go look and participate in the dialogue about what's happening.
How often are you looking at those things that people are submitting?
Well, the team looks at them daily. I don't look at them daily, but I participate in the design group for C#.
Got it.
And so anything that makes it into the language, I will definitely have been involved in the discussion. Yeah.
Got it. So let's get some more questions. Christian, when building apps, there always is some code inside HTML files. Will there be tooling refactoring to support TypeScript code inside HTML?
Yeah, I'm not sure I would recommend putting your statically typed code in the middle of an HTML page. I would probably urge some refactoring there, where you end up with the code in a code file and the HTML in an HTML file. Most of the modern frameworks work that way anyway, and encourage you to work that way. So I don't think we will see sort of a resurgence of TypeScript embedded in HTML.
Would you say that that's maybe a smell for this needs to be changed a little bit?
Well, it's just, I think generally speaking, you're going to do better when the two are separate, because otherwise The only thing that can work on your code is the thing that implements the union of the two, right?
Got it.
You can find a ton of HTML tools and you can find a whole bunch of TypeScript tools and IDEs that support TypeScript, but you're going to find very few that support
do both.
Both, right? So you're generally better off keeping these assets separate, I think.
Now here's another question. This is interesting from Tim. Did Microsoft have to re-implement the Roslyn compiler for Linux and OS X? I think this is going to bring into relief some of how this thing works.
Yeah, no, we did not. Because the Roslyn compiler is written in C#. What we did have to re-implement, or, well, it's not a complete re-implementation, but we had to implement the .NET CLR on OS X and Linux. And that's what the .NET Core project is about. Moving the code base that previously was Windows only onto OS X and Linux. And once we have that, and we're very close, then Roslyn will just work. I mean, it already works with Mono, right? So you can already run our compiler on those environments, but this actually gives us the same code base for all of the OSs.
So there's a difference between the runtime and what the compiler is producing, right? And so those are separate things.
Well, yeah, I mean, in .NET, it's like the compiler is just, in a sense, an application, right? I mean, that so happens to produce
applications.
.NET applications, yeah.
All right, so here's another question. I love the C# 6 features. So refreshing. What potential ideas are on the table for C# 7? We just talked about that.
Yeah.
So, which brings me to another question that's similar to that. There is this interesting intersection now between folks really digging the functional stuff, and then there's the imperative stuff that we do in C# with object-oriented stuff.
Yes.
And they're starting to come together.
Yes.
Where would you draw the line?
Well,
is there a line?
No, I think we're sort of proving over time that there isn't really a line, right? I mean, no functional programming language is purely immutable.
That's right.
Because you got to produce some output at some point. It's a question of how immutable you are, right? And functional languages tend to favor immutability heavily, where OOP languages tend to favor stateful and imperative. And we're sort of all exploring the intersection between those. I will say in the projects I've worked on, recently, or like Roslyn and TypeScript, it's a lot of the techniques we use inside the compiler, for example, are actually functional programming techniques, and a lot of immutable data structures. Just because there's, especially in this world of computing that we have now, where you have mutable state, and you have multi-threading.
Yeah.
And you can have one or you can have the other, but never ever do both.
Right.
I mean, because that is a recipe for pain, right? I mean, if you want mutability, you got to be really, really careful about just having threads run around and modify your state. But if you're immutable, hey, you can share with zero cost.
Right.
Because all your hand this guy reference is never changing, and so great, you can have as many threads as you want reading the same data, right? And that's always safe.
Got it.
And sometimes you just gotta that is, as a programmer, a very liberating way to think about the problem, because it is by definition safe. You don't even have to worry about it, right? And that's why I find immutability to be very attractive as a programming tool.
So are we going to see C# move more towards immutability and not?
We're definitely looking at. Of course, we are. We can't completely deny our heritage either. We are at the core an object-oriented imperative programming language, right?
Got it.
But certainly in the last many releases, we have added features that have all been very inspired by functional programming languages, and that will clearly continue. And immutability is one that we would love to formalize somehow.
Right.
Yeah.
Well, the saying goes, if you have a problem and you use threads, now you have two problems.
That's right.
Wasn't it Abraham Lincoln that said that on the internet? I believe it was him. Here's another question. How active are you on C# and TypeScript, which takes most of your time, and why? That's kind of like a good
These days, I spend most of my time on TypeScript, just because I ended up actually implementing a bunch of the compiler And so that's sort of where I get my hands dirty with my coding right now. But in the design space, I'd say it's 50-50. I mean, I participate in the C# design and in the TypeScript design process.
How much of the influence, did C# influence TypeScript, or was it like just a, we need to start again and think about JavaScript and then make JavaScript a little bit better?
Everything you do influences what you do from there on out, right? I mean, and Pascal influenced C#, influenced, et cetera, et cetera.
I think Abraham Lincoln said that too.
So yes, it did, yeah.
Got it. All right, any plan to add C#-like extension methods to TypeScript? That's an...
Yeah, probably not. I mean, the thing about... The thing about JavaScript is that you can already, in a sense, hack it. You can walk up to any object and start adding methods onto it. Uh-huh. And there's even like a technique called polyfilling that we use to emulate ECMAScript 6 in ECMAScript 5 environments by adding all of the missing methods to all of the system classes and objects, right? And so the problem that C# solves with extension methods is already, in a sense, solved. It's just solved in a different manner in JavaScript. And we do indeed have the ability in TypeScript to extend an existing type by writing two declarations for it. Let's say someone has written some type, some interface type. You can go write an interface type with the same name, and the two automatically merge at compile time.
That's cool. I didn't think about that.
So we do have something that's similar. It's just done differently.
So I don't know if people know this, but the new Visual Studio Code, what influence does TypeScript have on that? And I know I was kind of, because I know the answer.
Question there, isn't it? Yeah. So Visual Studio Code is written in TypeScript. It's basically, the shell it runs in is it's called the Electron shell, and it's a window hosting environment that was produced by the Atom team, Atom that creates the Atom.io editor. And the VS Code team uses that same shell, but then has implemented a different editor, an HTML-based editor, and they've implemented it all in TypeScript. And I forget how many lines of code. It's way over 100,000 lines of code, all written in TypeScript.
And the cool thing is that it was hiding under our nose under the code name Monaco.
That's right. It was an internal project called Monaco. It's actually been public ever since day one with TypeScript, because the playground for TypeScript uses the Monaco editor and the Monaco, all of the statement completion and language support that was in that little edit window, in a sense, has grown up and popped out of the browser. And
it's out of the flower pot.
That's an oversimplification, obviously, because there's a whole lot more stuff in Visual Studio Code. But I think the thing that I like about that project is that the team that has worked on it for these past several years has been dogfooding all along. So this is the tool that they have used themselves for years, and that's why this first release comes out looking so polished. Because this isn't really all that new. It's been around for a while.
So we have about half a minute left. What information do you want developers today to know about TypeScript? Where can they go to get started? What advice do you have?
Well, to get started, go to typescriptlang.org, and that'll pretty much link you everywhere. I would say if you're interested in the language or interested in participating, please come to our GitHub repo site and get involved. This is open source, and we've got a very active community there, and we'd love for anyone else to join in.
And I like it because when you say get involved, you don't mean get involved by writing TypeScript. You mean get involved by thinking about writing TypeScript.
Get involved writing TypeScript, but get involved in writing TypeScript too, if you like. Yeah.
Well, thanks so much for spending some time with us.
My pleasure.
Thanks so much for watching, and we'll catch you after the break. Take care.